The era where the company that builds the most factories wins is over. At least, that's how I see it. Infineon has just opened a new power semiconductor plant in Dresden, Germany. But the real story here isn't the number of buildings, it's the mechanism behind it. Using AI to link multiple factories together intelligently, they've made their ramp up to mass production twice as fast. That's exactly what we're digging into today.
Hello everyone, I'm Ty, with 31 years in the semiconductor industry. Today, using Infineon's Smart Power Fab as our case study, I'll walk you through how AI is reshaping the manufacturing floor and why power semiconductors are drawing so much attention right now. Stick with me until the end, and you'll see exactly why a factory's intelligence is becoming the deciding factor in competitiveness.
Here's the analogy. Picture a long-established, family-run town factory that has just added its fourth workshop building. But here's the twist. In that new building, they've taken the gut instinct of every single veteran craftsman, turned it into data, and loaded it onto tablets. So a brand new hire can simply follow along on the screen and suddenly work at the same speed as a seasoned master. That's the picture I want you to hold in your head.
Now, this town factory is constantly sharing know-how with a sister shop over in another town. Say the shop in Dresden develops a brand new menu item. It turns out the sister shop in Villach has already made something similar, and they can share that recipe instantly. So responding to a new customer becomes dramatically faster. That's the idea I want you to picture.
On top of that, this new building comes with equipment that recycles almost all of its water and reuses it, built in from day one. In town factory terms, it's like installing a system in the kitchen that filters and reuses the water from washing up, designed in from the very start. Building that into the blueprint from the beginning is quickly becoming common sense in this day and age. When it takes less time for a newcomer to make the same judgment calls as a master, the whole factory's output rises by more than just the number of buildings would suggest. You stop letting craftsmanship live only inside one person's head, and instead turn it into an asset the entire organization owns. That, right there, is what smart factory coordination really means. From here, let's get concrete about how this simplified story actually plays out on a real industrial factory floor. Now let's get into the real explanation. Infineon is one of Germany's leading power semiconductor makers. Headquartered near Munich, its core business is chips for automotive, industrial, and renewable energy applications. The Smart Power Fab making headlines this time was completed this year as the fourth manufacturing building at the company's existing site in Dresden. First, let's get clear on what a power semiconductor actually is. A power semiconductor is a component that handles the conversion and control of electrical power, turning the motor in an electric vehicle, converting solar power into electricity you can use at home, delivering a stable power supply to the servers in a data center. They're used in all of these situations. Unlike logic chips, which do the computation, power semiconductors are the specialists that handle the electricity. There's a bigger backdrop to why Infineon chose Dresden as its base: European semiconductor policy. The EU has enacted the European Chips Act, a law designed to boost the bloc's own chip production capacity. This factory is also receiving subsidy support under a framework called IPCEI, an important project of common European interest. The total investment comes to around 5 billion euros, roughly 5.5 billion US dollars, a large-scale investment by any measure.
What caught my attention most in this news is this one point: doubling the speed of the mass production ramp-up using AI. A digital twin is a system that builds a virtual model on a computer that is an exact copy of the real factory. By verifying the layout of buildings and equipment in advance and using AI to support the settings for the machines and processes, you can dramatically raise the accuracy of your preparation before you ever touch the real hardware. In a conventional semiconductor factory, it's not unusual for it to take anywhere from several months to over a year to get a new product onto the mass production line, because you have to repeat prototyping and adjust the conditions over and over again. Digital twins and AI make it possible to run through all of that trial and error on a computer first, and only then move to the real equipment.
The third pillar of that doubling is a concept called one virtual fab. Infineon tightly links its Dresden plant and its Villach plant in Austria through data. When qualifying the manufacturing process for a new product, in the past you had to verify everything from scratch at a single site. But by sharing data as one virtual fab, one plant can directly make use of a qualification already achieved at the other. It's only when all three come together, the digital twin, the AI-based upfront verification, and this site-to-site coordination, that the twice-as-fast figure actually holds up. The term 300mm wafer also came up. A wafer is the disk of silicon that serves as the base material for making semiconductor chips. The larger the diameter, the more chips you can make in a single pass. 300mm is the mainstream size today, and even in power semiconductors, the shift to 300mm is steadily progressing. It's a necessary investment to raise both cost competitiveness and production volume at the same time.
Let me lay out the main uses for the power semiconductors this factory will make. The first is powering AI data centers. AI computation demands enormous amounts of electricity, and demand is surging for the power semiconductors that deliver that electricity stably and efficiently. The second is renewable energy. When electricity generated from solar or wind is fed onto the power grid, it's power semiconductors that handle the conversion.
The third use is electric vehicles. Motor control, managing the charging and discharging of the battery, regenerative braking. A single car uses a large number of power semiconductors. Infineon holds a world-class share in automotive chips, so the wave of EV adoption translates directly into rising demand. The fourth is modernizing the power grid. The push to turn aging infrastructure into a smart grid is yet another tailwind.
The environmental features matter too. This factory reuses roughly 90% of the water it uses in manufacturing. Because semiconductor production consumes huge volumes of ultra-pure water, securing that water and its cost are major challenges. The plant is also designed to use no natural gas at all, with carbon-neutral considerations built in from the outset. Environmental regulations in Europe are strict, and I expect this kind of design to become the standard going forward.
The ripple effect on the surrounding region is also hard to overlook. On top of roughly 1,000 direct jobs, the indirect employment impact on nearby suppliers and logistics is substantial. Dresden is well known as a semiconductor cluster within Germany, and beyond Infineon, companies like Bosch and Global Foundries also have sites there. This investment further strengthens that cluster.
So, does this news have anything to do with Japanese companies? There's no direct Japanese involvement in this particular investment. That said, in the field of equipment and materials, Japanese players still have a major presence. And when a large factory like Infineon's comes online, it becomes an ordering opportunity for the likes of Tokyo Electron, Disco, Shinetsu Chemical, and Sumco. Even without direct involvement, being firmly connected as one ecosystem is a defining feature of the semiconductor industry.
Let me wrap this up. The essence of this news is that competitiveness is decided less by the number of factory buildings and more by how intelligently you connect your sites. Infineon linked Dresden and Villach as one virtual fab, combined digital twins with AI, and made its mass production ramp up twice as fast. I don't see this as a simple capacity expansion investment. I see it as a move that changes the very dimension of manufacturing competitiveness.
That's all for today. I'll keep bringing you semiconductor news and analysis, so if you found this useful, please like, subscribe, and I'll see you in the next video. This has been Ty on Semiconductor News Decoded.